That was a nightmare.
Yeah.
So
But for some reason, I checked this. I have to check again. I'm recording with OBS, so but also Google Meet, yes, has recording capabilities. But I see here it's like you're not even me, the creator of the meeting, saying you're not allowed to record this call. You're not allowed to
mm,
record this video call. Stupid. Anyhow,
stupid.
let's see. Yes.
Okay, here we are. I thanks for the creating the thread, the triple shot coffee. So yeah, I asked a little bit what are the topics.
Yeah,
There's a video.
maybe we should make multiple ones. Let's say.
Yes, I mean, let's. I'm just gonna. I'm just gonna keep some notes. Uh,
Give me 1 second. I'm picking up some coffee, and then I hear you. I'm just
of
helping.
course, that's compulsory. You need to have coffee to attend this meeting. So today is 23rd. Okay, so the Monday coffee at the Real World ML community. It's a place where we drink coffee.
I saw somebody also interested in this computer vision thing. I don't know if it's
Mhm.
Dream or something else, but
Uh-huh.
Cristiano, I think. I think he wants to
Then,
join because he's from Brazil or not.
yeah, Cristiano was actually, let me pull up. So Cristiano from Brazil, he said, uh, which, by the way, I'm really glad because he wrote to me yesterday. He got a job at basically like an AI fund in Brazil.
Nice.
So also he was very happy with the last cohort. So also credits to you, Marius. So
Thanks.
that's
We
that's a
did
nice KPI. Happy,
happy people.
successful. Yeah, happy ending.
Yes.
Uh, okay, so
We wait
Kubernetes.
another 2 minutes and then we start.
Yes, yes,
Okay.
something like that. So I'm just gonna copy some of the ideas here. So
Here you go.
Cristiano has this one here. Mm, mm, mm. No, actually, let me do it simpler like that. This is too complex. This one by Cristiano. Uh, Computer vision. Good morning, Maxine. Don't be shy. Don't be shy. I saw your face. Don't be shy.
Hi,
Hello.
Morning.
nice to happy to join.
Yes, of course. This is intended to be like a human-like meeting. Okay, so um, I once worked in a company, like a fully remote company, where it was compulsory when you attend the meeting that your camera is on. And the first time I thought, oh, so stupid. I mean, why? What do they care? But it really changes. Basically, first of all, your attention. Like it's no longer like this distracted, half following, half not following. Good morning,
Yeah, no,
Cristiano.
I super
Hi
get
guys,
it.
how's it
Uh,
going?
So yeah, Maxine, webcam on, obviously, unless it's like really something you need to hide. Don't worry, we're not gonna.
Okay, yeah,
Yeah.
I'll be a bit
Oh,
quiet today. Like this is my first time, so I don't know what's gonna
don't
happen.
worry. It's our second time, so
Okay, okay, cool.
yeah, we're there.
Mhm.
Where are you based?
So I'm in Manila right now.
Hi, Manila.
Yeah,
Nice. So what time is it for you? Like
it's
7 in the
5
afternoon,
p.m.
5 p.m.
Mm-hmm.
Mm,
Yeah,
nice, 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 nice. We're covering all the time zones. And Cristiano, you're in Brazil, right?
Yes.
Oh, and you have a cat.
Yeah, that is Juju.
Juju.
Yeah,
Juju,
Juju.
Juju. Now it's 6 a.m. right here.
6 a.m. Oh,
Yeah.
why are you doing that to your cat? I mean, cats are night animals. He was probably just hunting
Sleeping.
some
Yeah,
food. Huh?
yeah, but especially in the morning, she loves to be close.
Uh-huh.
because it's a little bit cold
Uh-huh.
in Brazil in June,
Uh-huh.
so she prefers to stay close.
You're welcome. We are recording already. We were just waiting a couple of minutes, and if you want, Marius, we can start. I'm just here, just like putting like potential like topics. I mean, topics, things that I asked in the community, and I saw some people showing interest. So just to recap, the first one, Zeno and Mundrin. This is something that Marius did some research he was doing for a couple of weeks ago. And we talked offline, the two of us, and it's super interesting. So this is one of the topics we can discuss. Also, Cristiano, you're talking about computer vision and also Kubernetes help. So Kubernetes on bare metal. So this is Kubernetes on bare metal tips and tricks. Or maybe Marius can share something like Kubernetes on bare metal. This is your specialty. So, and then the second topic is computer vision and ML. You're working on a CV, computer vision ML project to evaluate calisthenics athletics performance using MediaPipe. You plan to stream movement landmarks. Okay, in real time. So it's about real time image, only real time high dimensional data streaming, right? Something like this. High dimensional data streaming.
Yes.
Using Twitch. Okay. How to start? But I'm stuck on how to relate, and you want to detect, and you want to detect. And start and end of each exercise. Okay, that's one thing. We love to hear your thoughts and ideas. Super. Then we have some things related to LLMs and what we talked on Monday. So, which was deploying an LLM server. So basically, one of them how to deploy, how best uh, practices to securely deploy your own LLM server. So I mean, Marius knows these things. And agent observability, tracing, monitoring, debugging. Okay, so a little bit of LLM engineering here. Okay, I think we have enough topics now. I mean,
Yes.
just before we start, yes, they're interesting. Also, I want to say, for example, what Christian is trying to do is something that probably you will find value in this discussion with Zeno and Moondream because this is computer vision. So Moondream is a machine learning model which has been trained for computer vision. So if you want, Marius, we can kick it off like this, right? We can kick off with Moondream.
Yeah.
Feel free to explain. I'm just sharing some context. What is Moondream? So
I don't know. I did some research for something, but I came across them
mhm.
couple of months ago.
So
Uh,
I'm just trying Moondream. Yes. So Moondream is a computer vision model, which is also which has some semantic reasoning. For example, you can provide an image and you can ask something and it provides an answer. So it's basically what's called a VLLM, like a large language model, right? It combines
yeah.
multiple. But the distincting thing or what makes it powerful is that it's quite small. So Moondream, GitHub, it's a tiny vision language model, which
Yeah.
makes it really useful because this means you can deploy it in many places, right? So the original version is written actually, it's here. I think this is the official repo. It's
Yeah.
in Python, which is okay. But then obviously you can find a more efficient implementation in Rust. So there is Moondream implemented in a library, in a framework in Rust called Candle. So Candle Rust. And they have a Candle Moondream. So they have a re-implementation of the official Moondream in Rust, which obviously, I guess, if you benchmark it, you will see that this is way faster. The memory consumption is way lower. So this is basically the super, I guess, one of the most optimized ways to run Moondream. Okay. So this is the computer vision model, but this is just one of the ingredients. What Marius wanted to talk also was this tool called Zeno. And this is related to what Christiana wants to do. So if you want, Marius, just take it from here.
Yeah. So this was I looked for a compute also like a real time object detection, right? And let me share the screen and I will figure it out.
Yeah,
Where is
feel
that?
free. I'm just pasting links.
Yes.
Zeno.
Let's see. So object detection, but I was wondering how all of this is done in real life, right? All the time. And in real life, I was looking at GitHub. Sorry, screen. This one. I was looking for GitHub projects that are using it, and one of them that caught my attention is an implementation related to a robot, copying your movements right in real time, and like a robot training, right? And instead of basically touching the robot's arm to and moving it in different directions like they do it now, you potentially could do via object detection, right? Or the robot can learn after by looking at images that he sees real time. I found this project which is using Moondream and is using the Xeno component. Let's draw some things what it does. So
Can you share the link to GitHub to this
yes,
project?
give me 1 second. So Xeno Eclipse is from Eclipse and is a peer-to-peer, let's say, network stack. If you want to could define it as a network stack, right? But instead of having Kafka, you would have Xeno, right? But in Xeno you could have between two components of your software, like two microservices. If we can draw it, let's see if we can XKey draw it. Yes. New. To say, do we need this? Share.
And just a quick question: why Zeno and not using, for example, Kafka? Because this is about collecting. You're collecting images from a webcam, and you want to send them to your machine learning model, Moondream, right? It's like
Yes.
It's like streaming data in real time from the input to processing, and then eventually you're gonna serve it on the screen, right?
Yeah.
So why won't you be using like Kafka to do this kind of asynchronous real time communication? Why
Because
Zeno?
Kafka, it has it has a lot of network overhead, right? So you have to what in real time with robots and with other things, you need communication between two direct clients very fast.
So it's about speed.
Yeah. So instead of basically having, yeah, of course Kafka can handle communication like this, but it's a different. So with Kafka, everybody puts things there, right? So you put things there, and again, with Kafka, we have the same problem that you have to say how many partitions, how many consumers, right? So two consumers. If you have whatever, if you will see this project has two consumers, it's not straightforward, but why? But you need to define this with Kafka, right? In case of Kafka.
Mhm. And
So these two consumers, right? You have to define it, and consumer,
zero
consumer,
overhead.
producer. So and also what it was, it is interesting with Kafka. You will see a very big um, in the case that I'm talking about, the essence of it is processing frame by frame, right? The video feed that I'm going to share in a second. And frame by frame at even HD quality means a lot of data being put on the wire, right? So this producer would send data to Kafka like frame by frame, 30 frame per second or 60 frame per second. I don't know what you want. Like super high definition can be even 60 frames per second. If you want super high definition things, and I think people do this these days, not only like old things, 320p. So the high definition thing is a lot of space to store, right? So basically you would put this on a topic and then this one would consume it. In the end, the essence is very simple. Like you're putting frame by frame somewhere and somebody will send this to Moondream. Let's put it like this. This is Moondream here, for detection. but not frame by frame. It's an interesting approach. We will see it. It's not really a frame by frame, or not all the time. So this is not really like real time, frame by frame, 30 frames per second, sent to Moondream to do. I think they do it once per second. And we will see the code. And then they also do some nice, magic related to algorithm and extrapolation from it. But that's the essence. Let's see. Moondream is so basically what we start from left to right. So I have to install Moondream as this one. So quick start, install local, option B, local, right? So they packaged everything into this whatever, like Oyama, to stick to the Spanish pronunciation. So all of this is a Python. I think it's okay. As you can see, so it installs even on my MacBook a Python environment with virtual environment. So if we go there, we will see things that are and basically they are starting a server that downloads and serves this model, right? So in worst case scenario, I'm also thinking like this can be. I can look into the application, into this Mac application, which is essentially Python behind, and to run a little bit, like to understand how they package this. So if we would be running it in a container, then you know all the tricks behind it, right? And of course, they are serving this API v1 detect, exactly like any other whatever OpenAI things, OpenAPI AI, OpenAI, right, standard. So everybody is using the same standard. Okay, so we installed Moondream. This is running locally and runs locally on a port. And then all the other components. Let me see if we can do a little bit of yes, Carlo. Always interrupt me. I have no.
Yeah, no, I was just wondering, like, how come these vision models are so small? Like, because this is an LLM that can also like see, right?
Yeah.
So I'm assuming that they're not trained in a big corpus of knowledge as foundation models, right? But rather optimized to see and then be able to
You'd be
reply on
surprised.
questions, right?
There is on. I don't know. Paul was showing a little bit of. And then I will let Paul explain a little bit. Maybe he knows the answer, but I will show you the demo from them, and it's pretty.
Or maybe the language part doesn't have a lot of parameters.
Let me this
like,
one, right?
Uh-huh.
So, sorry, let me see if I can. So you see here, the vegetables are like how many whatever. But I did a stupid question like how many pieces in the beginning? How many pieces of jalapeno are in the image? There you go.
Yeah, so it needs to know what is jalapeno. So
Yeah,
it
and then
does have
fucking
some
pieces,
corpus of
and
knowledge.
even with my bad spelling, it's
Yeah.
quite powerful on this one.
So
I
how
don't know
come
how
they're
they
so small?
are. I don't know how they are trained. Of course, I think a corpus of images that are we should
Yeah, this is something that I don't know well, and it's a really good question. Yes, I didn't ask myself why they're
Yeah,
like
because
they're
you're running it locally. I mean, it has to have like 8 billion parameters.
less. It has 2 billion. There are two flavors, 2 billion and half a billion. So the half a billion model is 400 megabytes.
Okay.
Like,
So it's probably like a full-featured LLM, but with just a few billion parameters just to make it lighter, I guess, because it's more optimized to see rather than talking, you know?
yes, and I think also my intuition here is that these VLLMs, what are the images they use? What are the examples they're used to train these things? To train this thing, you need examples of label and image, right? Like what
Right.
Marius provided. You have an image, you have a question, and the correct answer, right?
Hmm.
And generation of these data sets, you can generate quite easily synthetically these data sets.
Absolutely.
Going the other way around. So basically, the data generation process, you have a lot of control, so you can make it very clean from the beginning. Because what we've seen in LLMs, in standard text in, text out LLMs, is that the first generation were huge because they were taking the whole internet to train them. Then when they found out that there's not more data, they started creating the data. And what Apple did, I think 1 year ago, they built the first generation of small LLMs. I think it was like 5-6 billion parameters, which were working as well as the 20 billion. But the difference was the training data was cleaner. So basically, you were able to, because at the end of the day, the model, what is internally doing is some kind of memorizing, internalizing the data because it's training. If the data is very clean, you don't need to waste too much time basically with noise, right? So if it's clear the signal in the trained data, my intuition is that you can use less parameters to reproduce to get the learning right. So, but
Yeah, you
regarding this is
can
just an intuition, but
you,
still it's surprising. They're super small.
yeah, you can basically distill a huge model that it's incredibly good and heavy and just put it in 2 billion parameters. Yeah.
Yeah, and
Yes.
also you can like it doesn't need GPU to run. You can run this on Raspberry Pi. Like
Wow. This is
That is pretty
incredible.
awesome. That's
Yes.
pretty awesome.
You
You
can
can put it
run.
in a drone and make it think.
exactly, like I
Put
think
it together.
the like
Yeah.
this field explodes very fast. Will explode very fast in object like detection related to aerial image photography or video feed, especially with
Super.
like I was pleasantly surprised by this because this setup network setup to communicate between these components with Zeno is very interesting because it's a library that adds a peer-to-peer extension to your microservice, right? And then the library takes care of itself. You don't have to communicate with like it only scans your local network and then it finds clients. So that's the peer-to-peer approach that they did very nicely, and it just works. Like I had zero configuration to for two components to communicate. Like it's amazing, and also it also surprises when it comes to the data transfer, right? Because it's transferring images on super high speed. You will see. So what is happening here is like we will produce images from my camera, one of my webcams, the image producer. So the image, sorry, camera. Um, and this camera is being whatever captured in this by this Python script. So this camera is communicate. The camera is communicating with the Python script. Via Eclipse Zeno is finding consumers, and one of these consumers is also talking to Moondream intermittently. So the camera, and then there is another project which is really you'll see it. We can see we will see the actual camera feed. Uh, Run deck it's called. Let's start it. Let's see if it works. Very nice. Where is my visual code? Yeah. So the code base. I'll share the links of when I'm done with this related to the repository. I did very few modifications related to this, related to libraries, and a little bit of like I'm trying to understand a little bit what's going on related to the Python code. So webcam publisher is just a very simple Python that is using CV2 and the Zeno library, right? It just yeah, uses a video feed with MJPEG, which is a very nice format to transmit over the wire, but there's not a lot of things to do. So the interesting thing is this Zeno, this one, right? So in the end, every image is sent on the wire with this Zeno library, right? Z session. We have a Z session, and buffer to bytes is actually the frame, right? So we are going to see if my camera, I have one camera here up, which is has already started to the feed, right? And now in the other part, so I'm leaving this to transmit the feed. In this other part, let me see if I can do a new terminal. So I start from scratch. So source vn, yeah, this one. So this is the camera web publisher is on the other terminal, and then the tracking publisher, and basically the robot servoing example is another component, which I don't have a robot, so basically this guy was also controlling the robot. So the tracking publisher will use this beautiful yes, so again Zeno here, CV2, right? Zeno, so this object tracking part is using Moondream. So this is the only thing that I had to modify, just to instead of using their cloud, just to look at the local Moondream station. So this is like Oyama, right? The basically in the frame, each frame is going to be decoded and try to detect what I'm trying to say, what I'm trying to detect, let's say. I'm putting I didn't do many things here. So Python in behind me, I don't know if you see it, I have some pine cones, and here we go. This is the rerun.io interface that they're using. This is the camera from here, and basically, as you see behind me, it's detecting the pine cones on my shelf behind here. And if I go and try to take one of these, I think it will. Hey, come on, see? It's already there, detecting it. And this is pretty real time at 30 frames per second and HD quality of my camera. So it works. Of course, it has some ghosting and whatever. Some things are being. The one in the back is also still there, right? And the nice thing about this also this I found out this about this rerun.io. These guys are using also Python and visualizing data and whatever. So video feeds and data on top of that video feed. This is what the Python code is doing with this rerun. The interesting part of it, sorry, is that you can pause this, right? And we can go back to whatever in time and see the video feed and the analysis of it, right? Which is super nice also, and understand I think from this basically the Moondream API is being called once in a while, as you can see, like this one. Every couple of seconds this is called, right? And it takes 4 seconds to detect. It's not it's a lot for me, but
Yeah.
it can be improved, of course. But it's also the feed, the let's say the camera feed is also a lot, right? We are looking at 8.4 gigabytes right now. As you can see, I was looking at this, how much data is being transferred back and forth. So a lot of data. If I would be putting down this the quality of this, it'd be even worse. Yeah, that's it.
Very interesting.
And I was thinking of the problem that Cristiano you're trying to solve, right? Which is
Yeah, for sure it's gonna help me. But the question, my first challenge is the calisthenics guys, they are making a kind of pull-up exercise. So they catch the bar and push the arms down and up.
mhm.
And I have to detect when the exercise or when the repetition is it's good enough to be computed. Like it's a viable uh, repetition. That's the mission that I have. And I developed a prototype using MediaPipe and getting the information, the landmarks, and make some calculations to make sure that the repetition is good enough. But I have to enhance a lot of analysis to give a lot of feedback to the athlete. And I'm thinking to use the lessons that we learned in the last cohort, like taking the landmarks. It's a swarm of landmarks. It's event streaming and get those events and create in different pipelines. But the thing that you show me, guys, it's a different approach. And the only question that I have, how I could ask to the model to evaluate if the repetition is valid. I think I have to produce a prompt or something like that to instruct the model, I guess.
Yeah. Of course. I think so. Yeah.
Um, I think, I mean, first, but before prompting the model, you need to collect a small data set of good examples and bad examples, right? You need an example of you need your evaluation data set basically, right? You need to find
Yep.
snapshots of this guy completed the exercise in a valid position or this guy completed the exercise in an invalid position. And when you have this evaluation data set, it doesn't matter if it's very small, then the first iteration would be to use a little bit of prompt engineering. So you don't need to start fine-tuning, forget about training, forget about complex, don't touch the internals of the model. Try with a little bit of prompt engineering, say maybe with Moondream. Please find
Okay.
someone doing a correct extension at the end of a flex. And you just use this kind of model and you evaluate it against your data set. And how do you evaluate? I mean, it's going to be a little bit tricky. I don't have much experience because now your evaluation like a stream of frames, right? And you need to detect the
Yes.
frame which is close to the termination of the exercise. And now you need to decide if it's good or not. I mean, we can think about that in the first iteration, I think the first important thing is that you get some reference data set of good examples, bad examples, and you evaluate your first solution. And if you're able to build this setup, in my experience, this is 90% of the work. If you're able to build a simple model and evaluate it reliably on your evaluation data set, the next iteration, if it's good, super. If it's not, the next iteration is going to be now I need a more complex pipeline, or now I need to fine tune my model using my images, or now. But then you will do some work, or however, like fine tuning, whatever. But then you will go again, evaluate, and be sure that the evaluation is right. This is the part. I mean, this is the part you need to do at the beginning. It's like this cold start problem, but it's the critical one. If you are able to come with this evaluation data set and find a reliable way that given a video stream, you give me a score and you can say this model is better than this model. Now it's all about, I mean, tuning the prompt, using a larger model, whatever. So, I mean, we can keep on this discussion offline because it's interesting.
Okay.
And I think the key here is evaluation. Like for anything regarding machine learning models and LLMs, if you're able to get a reliable way to evaluate your solution based on the problem you want to solve, that's 90% of the problem. Then adding
Yes.
complexity, it's honestly adding complexity. It's easy if you know how to evaluate if that works or not. But going the other way around is like a loophole you will never end. Like you will never know. You will never be sure if what you're building is actually reliable, which is the worst feeling ever, right? You will be able to put a demo and put it on LinkedIn, and say that you built something amazing, but you will be afraid when you're out there trying to pitch it and explain it. And this is
Mhm.
so
Okay.
yes, try to come up with an evaluation data set and a way that makes sense to evaluate a given video stream against that data set. If you're able to do that, you are
Can you open this one because you're sharing the screen, Paul? Can you open the last link that I?
yes.
So extra to what you are saying, I would do this. Like I've seen a lot of these things. I was looking at them how they're doing it. You need to invent yourself some markers and then decode them in the with the computer vision. Can you scroll a little bit down? And you will see what I'm talking about. It's like QR codes, but small or whatever. Even a little bit more down, Paul. There is a piece of paper which is being
The,
graphed.
the Aruco, yeah, I have used it in other projects. Yeah, go ahead.
A little bit more, a little bit more. There is a photo of a paper here. See? So the paper is there, and yeah, and then the like whatever your marker is below calculated. So you see basically like you can
Mhm.
see if the paper is in a position or not, right, or whatever.
Mhm. May I show you guys my prototype? Just one
Sure,
second,
of
because
course.
Of course.
it has the landmarks and all the stuff. I think it's gonna bring the real idea. Just one second.
Uh, mhm,
Okay.
mhm,
I think
mhm.
the
Nice.
example is a guy. It's a mobile application. It's a Django application running in a mobile environment. Okay. The challenge is imagining that the bar is up on me,
Yeah.
so I'm going to take it. And when I bring it down, and my wrists come uh, uh, down from my shoulders, I compute 1 repetition. So I have to pull up again and push down. So that movement between the wrist and the shoulder, the trick is right here. So I have to back down, back up, and push down again to complete another one. And all the landmarks that we are seeing, it's generated by the media pipe.
Nice.
So that's the end.
I would also do like so you're putting your camera right straight to your face right now, like you're. But I will also do the other angle, like 90, another camera with
Yeah,
another angle, like
I
90-degree
have
angle.
tested. Yes, I have tested different mobiles, different cameras, and it works. And the parallax stuff, it's well resolved by the model. It's very interesting.
Nice.
So, but the thing is, uh, that's the first part. The second one is how to analyze all the events that we have right here. I just capturing the event when the shoulder pass above the wrist. Okay, and I capture the image and send to an S3. Okay, just to have some data. But the thing is, how to calculate the acceleration and how to calculate the power that the guy are using to make the ups and downs. So that the kind of feedback that is really valuable for this like kind of uh, exercise calisthenics. So
I don't
uh,
know if camera vision would like I think you need a physical accelerometer, like a physical sensor.
mm, maybe
I
Uh,
mean,
Yeah.
I was thinking that if what you're trying to find are ending positions, because for example in your video, I was thinking if you put your arms down and you just lift a little bit and down, this will count as repetition. You will be fooling the model.
But the
Basically,
thing
what
is, you have to start on
Uh-huh.
up and bring it down below the shoulder.
Mhm.
It's a variable exercise, and put it back. Okay, that's the trick.
Yeah, so
Okay.
there is a lot of. How do you plan to store all these? So you're storing the image, but also your markers. Are you storing them like for
Yes,
that
I'm
image, for
storing.
that frame?
Yes, I'm storing a few ones, but that's the second step that I asked you guys. How the best way to store all landmarks? Because there are a lot of landmarks. It's 300 milliseconds. There is
Try
an
this
reward.
rerun.io for sure. They have this.
Okay, okay.
Yes.
Yeah.
I took a note. Yeah. Okay.
They have some robotical, like
Mhm.
physical thing for the robotic part where you could analyze a lot of things. Like
Okay.
you can
I
overlay a
think
lot
Great.
of things and then you can analyze in rerun. And
Mhm.
the let's say the API is very nice. I
Okay.
was extremely impressed with it.
Okay. Okay. Because I was thinking about that approach. Kafka plus QuickStreams and make a windowed calculation. And the challenge was how to detect the initial of the repetition and the end. Because using QuickStreams, you just set a window interval and make some average calculations. So that's another challenge. But I'd say that I'm gonna check the rerun.io and all the
This
stuff
one
that
I
is
saw it and I was looking at it. So
Mm,
human pose tracking
great.
from different
Okay,
camera
guys, that's
angles.
it.
Yeah, it's
I
nice.
don't want
No,
to.
don't worry, it's fine. It's fine. Also, the project is super nice.
Mhm.
no.
But
I mean, my thought just to dump them before we change topic. I mean, at the end of the day, you're collecting like a cloud of points, right? You're transforming a raw image into like a collection, a list of points of 3 coordinates, right?
Yes,
yeah,
And you
yes,
track them over time, right? So you get spatial information over time. So if you want to detect
yes.
particular positions, you have that done. If you want to
Mhm.
detect the beginning or the end of the exercise, it's related to what you were asking. It's about the rate of increment of these coordinates, the speed, right? This is physics. Or the second derivative is the acceleration. If you get the points,
Yes,
in principle, you can get these numbers because this
yeah,
is
exactly.
basically you check the differences over time. The thing is that
yes.
the more velocity you can get it, acceleration you can get it, but the approximation will be very rough because there's going to be a lot of
Mhm.
errors there. So if you don't track acceleration using another device, only the points, I don't think acceleration you can be reliable with that. The beginning or the end of the exercises are the points where velocity speed is 0.
Yeah,
So if you're capturing a stream,
Great.
if you're tracking a stream of clouds, and you have the timestamp
Mhm.
and you have the coordinates, you can basically check the first order differences between one frame and the previous one. You divide by time. And basically when you see that the increment, you will plot velocity and you will see velocity starts at 0, basically peaks when you are in the middle of the exercise and then goes back to 0 when
Mhm.
you're done and then starts again. So if you're able to produce a stream, so basically you do a real-time data transformation of your cloud of
Mhm.
points into the speed of the system. And this thing you can plot it with rerun. It's going to be super nice visualization. You can plot in rerun the stream of video, the stream of the cloud of points over it, and the velocity of the system. And I'm sure that you're going to hit like 0, peak
Mhm.
0, peak 0.
exactly. Yeah,
And this,
the
this is a way.
the nice thing about the rerun, exactly like Paul says, you can see in the also on the screen the guy who was playing tennis, right? That's
Yes,
the
exactly. Something like this.
exactly. So that's the movement and
Mhm.
that's exactly that one. Yeah.
Yes, exactly.
So
This is exactly the
Okay.
movement.
zero and ones in terms of
Mhm.
digital signal processing, right?
Mhm.
Yeah,
And
0 ones, and then
to. Mhm.
yes.
Okay, sorry. You
So
can.
yes, I think it's an interesting problem. I think you can get quite far with what the data you have. So
Uh-huh. And the last thing is, I'm capturing the landmarks. It's a matrix of a lot of measures about the landmarks. I mean, the wrist part, the shoulder part, and I'm not storing the image itself, just a screenshot when the movement is good enough. But I don't know if I'm using the Django channels, using a WebSocket to transmit it in real time. But
This
I
Zeno
think,
is extremely fast also for that part. It's faster than it would they claim is faster than a WebSocket, even a
Mhm.
WebSocket.
okay, I'm gonna try all this stuff and tell
Yeah.
you guys next week.
The also of course a WebSocket is the fastest thing that you can have, but the WebSocket is not let's say you have to split your services also, so and implement the WebSocket thing, right? And the
Yes.
Zeno part, which is interesting, is I'm not I'm not I didn't set up a third client, but as you saw, there is like publishing the images on the wire on my network has zero
Hmm.
configuration. It's just
Yes.
behind it. It will detect a publisher and then subscribe to it. That's about it.
Mhm.
So
And is
yeah,
it
it's Rust. Yeah, of course.
and is it that it's 99.9% of it is Rust,
Yeah,
so
I agree.
yeah.
it's supposed to be fast.
So
So
Yeah.
the library, but also the let's say the also Zeno can have a server, right? So you can put also a server if you want to
Uh-huh.
persist data. So that's also an interesting thing to do next time.
before
Yeah.
we close this,
Great.
can you share the link to the GitHub repo, Marius, that
Yeah.
you showcased? Because this is a good like a good example of putting together the webcam, Zeno, and Moondream, and rerun. So these four building blocks to build something. Um, I mean, interesting.
Great, guys.
Well,
Appreciate it.
Don't
Thank you
worry.
very much.
super. So what was the second thing? And this coffee is. I mean, I finished my coffee. I will see what we do next, and then I'm gonna make myself a second
There
coffee.
you go.
Yes, Kubernetes on bare metal, tips and tricks, best practices. And then today at the beginning of the session, I saw that Rohit basically was asking for some RAG advice. So let me copy it here. So he's building a RAG application, RAG advice. I don't know what we want to do.
Do
Sorry.
it because I need to pour another coffee. Answer this
Okay.
one, and then I will come back to the
Okay.
Kubernetes part.
Yes. Okay. Then let's do the RAGing. So Rohit, you're building a RAG application on legal documents. It's almost 7-8 categories and almost the complete vector DB is 20 gigabytes. Can you tell me some retrieval practices while doing that? What's the problem? So Rohit, can you elaborate? What's the problem you have? It's like it's very slow or it doesn't work.
Yeah, it is not slow, but sometimes the data is there in the database, but still it doesn't retrieve it. Sometimes the uncertainty, like sometimes it retrieves and it doesn't because the database is too huge and the categories, the layer in the RAG application is increased much more because like the query is taken inside. After that, I am creating a task identifier to identify the particular task or category. Based on that category, the particular DB is activated or called for the relevant documents. So in that case, sometimes the retrieval is not done properly. None documents or chunks are retrieved. That's the issue. And sometimes it works too. So I am not able to make sure that what wrong I am doing.
Okay. One question. How are you? What these documents are text documents? How do you? What database you put them in? Like, what does it look like? The RAG
I'm
document.
using I'm using ChromaDB, and before creating embedding, the data is stored in a CSV file in text format. Means it is
Uh-huh.
in text, but a CSV rows. Yeah.
CSV file. Uh-huh. That's interesting.
Yes.
So basically you have a bunch of CSV files, you get embeddings. What model do you use there?
For
How do you
BA
embed them?
large model, large
Yeah,
base
but
model.
do you use something open source or use something like from OpenAI, for example?
For generation purpose, yes, I'm using OpenAI.
Embedding
OpenAI
model from
Yeah, for embedding
OpenAI.
model, I'm using Hugging Face. No, for embeddings, we are using Hugging Face, small base model, large.
Uh-huh. Okay, use something open source. Mhm.
Yes.
Okay, and you put the embeddings. So you put the embeddings, the ones and zeros. So vector. Okay. Mhm. I guess that you chunk and you do these typical things, right? Or not? You don't need to do that. Do you chunk the documents and then you embed them? Or
Yes.
okay, so something like this.
Like every like in the vector in my database, I have multiple databases. I'm not clear. In one folder, I have multiple vector databases for particular categories, so that it doesn't get jumbled between two vector databases and merge the
Uh-huh.
data. To keep
You
it
group them.
separate, yes, I have grouped them like vector one is for legislation or constitution documents, and another vector DB is for some acts or state-wise legal documents. Like that, it is categorized.
Okay. Okay. So basically you have separate like categories, right? And you have your rack, which is a Python script, right? It's like a Python script. Python script where a user sends a question, right? A user sends a question like, I don't know. It's a question that should be answerable using this information here, right? So the user asks, I don't know, what are my rights? I don't know, what are my rights as a citizen of this world? Okay. And now, obviously, to answer this, you basically need to fetch some documents. Okay. It's a bit noisy.
Yeah, like I have created a layer where it will identify which task it is, and then the particular task is detected, then the particular vector DB is called, and within that DB, the query is used for the relevant fetching the relevant documents.
Okay. And
And
but I need
for a
to
catch, I'm doing like two things. First, I do multi-query for retrieving the particular document, and after that, I do hybrid search to get the particular chunk in that document. So that's how I do it.
yeah. I mean, okay. I mean, retrieving documents, there are different ways you can retrieve documents. And you don't know in principle what's going to work best. You can retrieve with keywords, you can retrieve with hybrid search, you can retrieve with vector embeddings, you can retrieve using. So what I would do honestly to investigate this is I will write an evaluation data set of the system. So for example, I will look at the data and I will find questions which the system should be able to answer correctly. So for example, if in one of the now it's very noisy. Can you please mute yourself, Rohit?
Yes.
Okay. So I was trying to say, if you have problems with the retrieving part, then you should build an evaluation for that, which means that look at the document that you're embedding. So look at the raw data here, okay? Because there are a lot of pre-processing things that can go wrong. Like if you're chunking, if you're embedding, I mean, if you're chunking, embedding, and then retrieving, there are three things that can go wrong, okay? You don't know what. But you should build an evaluation data set, which means look at the original documents, open them, and find some questions which it will find some information for which you know that's going to be the answer to a question. Like for example, if you read in the document that I don't know, I'm inventing, okay, I'm very stupid, but dock owners between 5 and 7 cannot take the dock in the bus. Okay, this is how much I know about law. Then, if the system works well, and the question you ask to the system is, can dock owners bring a dock, or between what time can dock owners bring a dock to the bus? Okay, this is the example. If the system works fine, you know the answer is there. You know the answer of the system should be that. So try to build the same that I said for Cristiano. Build basically a data set. It doesn't need to be large, maybe 10 questions, which you know the answer. So you know that it's a golden data set, and you evaluate your system. And your system obviously is, this is basically the first thing to understand if your system is first processing the data well and retrieving well. It's like an end-to-end test of your embedding, of your chunking, embedding, and retrieval. And if in the first iteration, basically you do chunks of that size, you use the embedding model from OpenAI, and for the retrieval, you use hybrid search. My intuition here is what matters most is how you search for the data. The chunking here, I don't think it's going to be so important. But you get your first version of the system and then you evaluate it. And maybe you see that out of these 10 questions, 7 are right now and 3 are wrong. So now do error analysis and say, okay, the question of the dogs not finding was wrong. Why is that? And to debug this thing, basically, you need to do something, which we did in the last cohort of the real-time ML course, which is you need to add some tracing to the system, right? So basically, you need to, which is related to one of the other questions we got today, agent observability. What I would do, I mean, there are different libraries to that, but you can use GitHub OPIC. So basically, add traces to the system. So basically, understand every function of your workflow, what are the inputs and what are the outputs. So for example, when the system was not able to respond correctly, that piece of information, was it because it could not find it or because it found but it was incomplete? So basically, you try to understand what's the cause of the problem and say, okay, maybe the chunking is wrong. Maybe the way I chunked the data set was completely arbitrary and I chunked the data set precisely in the middle of that question. Then obviously the system is you broke the system, right? The chunking is not right. So maybe you should do chunking with overlapping. So basically, what I'm trying to say is the same approach with Cristiano. Build a simple data set with 10 questions with answers you're sure about that are in the documents and test your system and test if it answers correctly. So this way you will understand, basically you will get some confidence. And this is how you build an application that works, right? Because now you build the system, but then in 6 months, your client comes and said, we need to improve it. We should add something else. But how are you sure that now that you're improving the system, that you're adding more things to the system, you are not breaking what was working before? So you need this kind of regression analysis. You need evaluation and testing in order to guide your iterations. So, and this is what I would do, honestly. I would like to understand, I would like to assess first how good is the model on a reference data set. And when it fails, go to OPIC. So if you use OPIC, let me show you here. You can use a serverless OPIC that you don't need to install anything. You can use, you get a free API key. So basically with OPIC, you can add traces. So if you go to the documents where it is documentation, you can add traces. So you can log traces, which means that every function, so this is what you're going to see. Every run of your bot, you will see each of the steps. The data got in, it looked for the chunks. These are the chunks. I mean, all the functions, all the steps in your workflow are going to be logged. And this is, for example, an example. Let me sign. Here it is, for example. Look at this. This is an example of a basic retrieval. It starts with basically a chain which retrieves context and generates response. It's essentially what you're doing here. It's 2 functions. Each of the function has a track decorator. So basically you will see what are the inputs here and what are the outputs. If you see that the outputs are not fine, meaning it cannot find the document, you know where is the problem. The retriever does not work. If the document is there, but the generation part is wrong, maybe this is the problem. I mean, it's not going to be here. The problem is going to be in the retrieval. But basically, you can break down the retrieval into sub-steps. Because the retrieval, maybe, I don't know, there are several intermediate steps. You can also add tracing at that level. So basically, do this kind of evaluation and error analysis, and you will see why it breaks. And in my experience, I think hybrid search is quite powerful. If you embed the documents, right, it should work. You just need to basically tune a little bit some parameters. But yeah, this is in a nutshell how I would basically attack this thing.
Thank you. I'll try it.
Yes. And look, we still have we have 2 minutes, but we can make it 5. I don't know where is Marius and where is his copy. Okay, if you want, you can take this Kubernetes on bare metal, because I think this is something. Yes, you can all enlighten us.
I have a very straightforward question regarding the Kubernetes. It is I'm building a cluster, a Kubernetes cluster right here in my table, but I would like to know the container runtime, the containerd versus Docker. Which one I would choose to
But what Kubernetes are
build?
you running? What Kubernetes
Sorry?
distribution are you running?
Which Kubernetes?
Yeah.
Sorry,
Yeah, what Kubernetes distribution are you running?
I'm following
No.
DigitalOcean cheat sheet.
But DigitalOcean, yeah, share the link. Let me see.
Yes.
But DigitalOcean is probably like until I see the link, I probably think that they are advising you to use their Kubernetes or not. Bare
I'm
metal
following
Kubernetes.
this
Okay, this
this
one.
tutorial.
Yes. Okay. So Ubuntu is
They're
better
telling me
for
to use Containerd, but I don't know if it's gonna be a
yeah,
good
of course.
choice.
So Containerd is the most 99.999 five nines. Everybody's using it.
Okay. Great.
Let me see about this kubeadmin, kubelet. Okay, basically you took the very hard way of this. It's fine, but no.
Yeah, that's the way I found to learn the roots, you know.
So this is running the so Kubernetes as a distribution, right? It's again one step back. How I like to say it, Kubernetes is a web application, right? In the end, everything is a web application. uh, it's written in Go, and what it does, it communicates to the container runtime environment what to do with containers, and the rest is just things on top of it, right? In the end, it's a web application. So you can look at it as you can run the most in a most it's not primitive in a sense of being primitive, the most raw version of Kubernetes, right? This is what DigitalOcean is teaching you to do by using this kubelet, which is coming from Kubernetes. As basically they are teaching you how to install Kubernetes as if they install it on their own, right, with their own engineers. That's how they are teaching you in this
Yeah.
tutorial. So this is how they are running things inside. But my
Mm-hmm.
suggestion is go to Talos. It will be much more helpful for you if you have a dedicated machine for that.
Yes.
Look into Talos Linux. It's gonna
Talos.
be
Oh, I have heard something, but I
Talos
didn't
Linux is
check it
just
yet.
you put the image on a USB stick and you boot and you have Kubernetes. So it's Linux with embedded
Ah,
Kubernetes inside.
okay.
You don't need to configure anything. You just, of course, you will not have to configure after. You can ping me if you want some tips and tricks. But
Okay.
this is so choices are like a lot of choices are already. Why
Token
I'm
by the.
advising this is this tutorial you're gonna start asking questions. How I'm doing the networking, what do I do with the firewall, what do I do
Yes.
with this, what do I do with that, right?
Mm-hmm.
Cut it out and go to Talos, and Talos will give you all of this and running Kubernetes. So that's it.
Great. Talos, T8AL.
Talos Linux,
Yes.
can you do it, Paul? Talos
Yes.
Linux, Talos, yes.
Ah, Talos. Okay.
This is something that only crazy scientists use, like Mario.
No,
So
not
yeah.
true, not true. So again, this is a so Talos will give you it's a Linux that you don't have to touch like you would do with Ubuntu to update packages and other things. So it's a bare bones Linux distribution which has Kubernetes inside, and also it has an API. So you will be communicating with Talos Linux via like a CLI tool to
Great.
do stuff. And
So
if
no
you
SSH.
yeah, no SSH, no package updates, no this, no that. So basically, you have a lot of things taken care of for you. And most of the
Great.
things that I use, I have my own implementation of, let's say, networking between two nodes, but they already have that. I will send you. I don't have the link right now, but if you have a node in Brazil and you have a node in here in the Netherlands, then Talos Linux will has already the setup and the networking components. You just put it in there. I want this setup to be there, and these nodes will be communicating.
Great.
In DigitalOcean tutorial, you will spend 3 months to achieve that.
Yeah.
And you will,
Okay.
yes, so basically, it will not, what I like is tools that are like, if you have a target, follow the target, keep the target in sight all the time.
Mhm.
Your target is not to administer Kubernetes, you understand?
Yeah. Yeah, for sure. Okay, thank you, guys.
And
Okay.
yeah, and if you have a GPU, do you have a GPU on
No,
your
no.
machine there?
It's only old notebooks that I used to
Yeah, sure,
use
okay,
in
no
the
problem.
past.
That's fine. So Talos already has the NVIDIA GPU embedded into it.
Okay.
So basically, if you put a GPU, if you have a node that you find a video card, and you put a
Mhm.
node in your home with a GPU, then the drivers are already there. The NVIDIA drivers are already there.
Great. Got it.
And
Okay.
yeah, going back to the initial question, like Docker is you have to they changed their licensing a long time ago, and yes, it's like in terms of speed is the same thing most of the time, because underlying containerd and Docker use the same underlying thing. So there are
Okay.
several things under it in Linux until this virtualization, it goes to the kernel or to the memory, right? Because that's the most important thing. And Docker uses the same thing as the containerd. The only thing is that we don't use Docker, and nobody uses Docker because of the license.
Got it. Yeah,
And
now remember.
yeah, it's
They
very
have changed.
yeah.
Yeah.
That this is why everybody using containerd, and everybody's trying to do it
Makes sense.
containerd. But with containerd, you also have if you don't install Docker, you also have a command line tool like Docker list, this, that, right? CRI, yeah, getting started. Yeah,
Okay, guys.
that's
Got
it.
it. Great.
So you have all the tooling, is just named differently, right? Just
Mhm.
like with the Docker desktop. And this one doesn't have a Docker desktop. Yeah.
Mhm.
That's
Okay,
it.
so there are two things here. There are Docker files and the Docker runtime, right? And it's like that's the company developed both, right? I guess, and then so
Docker
develop the
files, yeah,
standard.
it became like the Google verb, right? So Dockerizing became the Google verb, equivalent to the Google verb, right? You Google something,
Mhm.
that with other search engines, it was not established, right? You don't
Mhm.
Yahoo search, you do yes, you whatever. So Docker came up with a thing, and then people developed alternative. Like it was a little bit. I think I don't remember if it was a fork or not. I have to dig into it from Docker, but I think it was an alternative implementation. This one, containerd. It was a little bit more
Mhm.
faster. Also, Docker adopted it. I hope I'm not wrong. Um, I don't know the
And just
history of this.
one stupid question:
Yeah.
if I build an image with the Docker build, can I run it with
Of course,
containerd
all the
run?
time. Yeah, everything is.
Awesome.
I hope so.
Okay.
Yeah.
Okay.
So every like Docker, you're using Docker on your desktop because it is the most accessible thing to enter in this
Nice.
world. But the next one I told you already, like can be Colima on a Mac, right? I'm using Colima.
Mhm.
Colima.
Colima, yeah. Uh, Colima, yes.
Mhm.
And in the end, yeah, it's not a Docker desktop. You don't do the same. In the end, it's the same thing on a Mac, right? It's a virtual machine behind you,
Mm.
Mhm.
behind it. And
Mhm.
also with Colima, the nicest thing about it is I can with Docker. Like why I'm recommending Colima, because you can also set up a machine think of this thing that we were doing with POW with Ansible and Ubuntu and installing the drivers, right? Remember that? On Paperspace and other things. So the testing for that, I'm doing it in a virtual machine, in a true virtual machine, not a container, with Colima, right? So with Colima, I can spin up a Docker, Ubuntu 22.04 virtual machine, separate from the one that is using Docker.
Okay.
And it's like VirtualBox, a headless VirtualBox, if you want a comparison.
Nice.
That's
Super.
it.
Guys, I'll need to go.
Don't worry.
We are
Me too.
10 minutes over time.
I
I think
have
I hope you enjoy your coffee. I enjoyed mine.
Yes.
Yes, the recordings they're gonna be available like a little bit later. Once we upload them, I'm gonna paste it on the channel. And
Okay.
yes, I'm very happy. I'm very happy you all came here with your webcams on. I think it was super nice.
Thanks.
Great.
And yes, next Monday, next Monday I won't be available for the coffee, but obviously, this is
I think I will.
if you.
Yeah.
Yes, if Marius, and if we are not available, it's fine. It's like this is a community thing. I just want to be, I won't be able to attend. But
Okay.
super, guys. I wish you a
Maybe
good
next
day.
Monday we do while you're not available. Yeah, we will see maybe we'll see because I looked at the channel and it was a lot of asking about the LLM deployments. So maybe we should just show how we do it. Hands-on.
Yes.
Okay.
Oh, hands-on. Yes, that was good.
Yeah.
Okay. Have a great week, you guys. Thank you very much.
Thank you.
It was
You
a
too.
Thank you,
Bye-bye.
guys.
Thank you.
Bye bye.
Bye-bye.
Bye
Ciao.
bye.